I'm back to do more calculus. I'm seeing me. Hey, am I making connections? As we progress in this video, what's going on? So, like, make a graph of a shark. Like, I just manually went and put a ton of graphs into the overall to make a shark. And I was like, find the like this much I can do with the shark graph. Oh. Um, by using all the arc length things. I don't know why. Sorry. So once again, so let's go through it. Got our first line up here. Got the derivative of that to plug it in. Plug it in. Math answer. Same thing. You know, second, like, it's corresponding to all the different graphs. I know I didn't really lay that well, but trust. So same thing, derivative, did math, answer. Now for the graphs that, like this one, is this little guy, straight up down, you can just count. And so that's what I did. So that's why you'll see some that don't have like any work at all. Here, same thing, plugged in, weird bounds, but that's okay. And I ended up using the same line equation twice and then just had different bounds. So it's then so we already figured out as a general equation of it, which I wrote here. So then I just plugged in the bounds and got an answer. I didn't go through all of like explaining it again. And then we had some really easy ones where you just counted. So you might be like, hey, I remember that up here there's a tangent function and a sine function that make up the main fin of your with tangent sine functions. Right. Come to a conclusion, and that can do it. I have spent other things to think about. So, yeah, I'm not working this. All right. So our function, there's the derivative, so we plug it in. So you see this. For simplicity, I just wrote that as m sometimes in here. Also because I didn't want to write these bounds out every time, I just now so I started going through it, set up the thing. A secant squared before I so I'm like, okay, let's get to the fourth. We can use the okay, I don't have that. I can rewrite one of these plus tangent squared equals secant squared. But then because it's not exactly a 1, that's where the 0.225 comes, or 0.25. Here's Pythagorean identity. And I'm like, oh my god, now. It could fit in to this format. Alright, what if I just, keep expanding it? Like, you said. So I expanded it, and then I was like, hold on, I can have a really smart moment here. Then I can break it up into 2 radicals. And then I went down some terrible routes here, and I was like, wait a minute, multiplication again, I can break up these radicals. So then I did this, and I was like, wow, outside of the radical, I'm making progress. No, look at this. This is not progress. Now I have a tangent and a cosine problem. Like, yes, I did it myself. But I didn't. Oh my gosh. No. And so then I was like, wait a minute, tangent, sine over cosine. And I have a cosine squared. Maybe, cosine's in common. And then I was like, maybe I don't do u sub, but like, I just put a u in there real quick for fun. I don't even know, okay? TLDR didn't end up working out. Now there's another time I tried this. It's much worse. So here, once again, I tried to u sub. However, here's where my slot came in that I didn't notice until a hot minute later. So I'm like, u sub u secant squared, like I'll just do u squared, and then the secant squared, which is right here, will be my du. Well, that's secant squared, as you can see up here, because if no, split this up, let me, here. So if you split this up like this, which is how I wanted it to, you can see that secant squared is still under the radical sign. So I can't, that's why I put the question mark here, because I was like, would the du be radical du? Yes, and you can't do that. So, and then you can see me still, even though that's not how it fucking works. Honestly, I couldn't tell you what I did. Not I remember seeing this on one of the old assignments, and I was like, surely that can help here. And then this is just the process of plugging it in and numbers and stuff. This is what and I saw this, and I said, hey, so I didn't write out an equals. I'm done. Now you might have noticed the change of the last three here. Working on it. So we have the last picture. Just one. I tell you what I have stuff because I mean it. I mean it. This is to Dr. And also I procrastinated. And it's a little last possible office hour. That's funny. When I say that I was being unwell. So, we're just gonna say it's impossible, can't do it. And it's 8117, alright? Now, that's not all. There's 2 parts of the fin. There was a tangent and a sine function. Here's the sine function. Unfortunately, we're trying to figure it out by hand, but because I chronically use dry erase boards, I erased it, you know, it's in the name, without taking a picture. So unfortunately, I don't have a lot of that work. But as you can see, I got to this point, and I tried a couple of different things to you know, break through this. And there's this one honestly could be possible. I could see this one being use the Pythagorean identity with cosine and sine. But my brain was trying to do the tangent thing. I'm not even gonna lie. That I probably did a lot of things wrong in trying to work through it, but at the end of the day, I could come up with an answer by my hand. So again, we're going with the computer one, which is right, like right, and it makes sense. But yeah, yeah, this was. I thought it was gonna be silly funny sharks. Thought it was gonna be silly funny shark time. No, it was not. But anyway, the part that you've been waiting for, you add up all those together and you get 1.6.674. And let's go look at our shark here. We only go to what? Is that 85? Something like that? 84. 84. So if it was less than 84, that would be a problem. What? It's not. And I like this answer. I feel like it makes a decent amount of sense. I'm okay with it. I know I mentioned that I initially into this wanting to do. I was like, I'll find the perimeter and the area. I think I ended up finding some more interesting when it came to that. By interesting, I mean it took up way much of my time. And also, I'm not going through that whole tangent thing again, even though I did it to myself. Which brings me back to point.